Right, welcome back everybody. I hope you enjoyed your lunch. So now we're about to start the afternoon session, and I would like to introduce Linda May from UK CEH. Her talk today is on leveraging water for climate resilience, adaptive responses to climate-driven water quality issues. That's quite a mouthful. So I'm now going to hand over to you, Linda.
Okay, thank you very much. Can you hear me? Yes. Okay, so the subtitle for the talk is Protecting Scottish Lochs from Climate Change, and that's the headline that the newspapers have been running at the moment about this report, so we can ignore that long one. So just to, we were talking about world water quality problems a little bit earlier on, and it's just really to emphasize that we have 30,000 or so standing waters in Scotland, but there are many, many more around the world. And globally, nearly 1 billion people live within 5 kilometers of a lake. And about 100 million people rely on untreated surface water for water supply. So the quality of those lakes is really very important. Okay, so back in 2020, there was an article published in Nature. And you can see here, these are temperature anomalies for lakes across the world. So the more red they are, the more they are above the average temperature for the area. And what you can see there is that lakes across the world are all warming up. So we took a look at Scottish lochs. SEPA very kindly shared their data with us, the temperatures that they've been measuring over about 30, 40 years. And we produced this report in 2022 on how much our lochs were warming. And I think everybody was really shocked by the results. We certainly were. So just giving you examples of the maps between 2015 and 2019. We had lots of other years in between. But what you can see is that the lochs get increasingly red. So if they're blue to yellow, that's the average temperature. 2015 is about the same as it was before then, although they had been increasing. Very suddenly, after 2015, there was an amazing increase in water temperature right across Scotland. And by 2017, quite a lot of them are getting into the red, and the reason we've taken that threshold is because that's the threshold at which algal blooms get triggered. The temperature threshold at which algal blooms get triggered. And then by 2019, even more of them were starting to go red. So then we frightened ourselves even more by producing some forward projections to 2080. What will our lochs likely be like in terms of temperature by 2080? And you can see that again, they're getting increasingly red by 2080. Most of them, of the ones that we had data for anyway, will be above that threshold where they'll be producing algal blooms. Caused a lot of interest in the media, and here are some of the headlines, but this one's my favourite. Is Loch Ness getting too warm for the monster? And that one flew across the world, and we were contacted by a TV company from the States who wanted to come across and discuss this with us, but I declined. So warmer water equals more algal blooms, and you can see that from this graph here. I'll just explain it to you. So the temperature increases in the y-axis, and the phosphorus concentration in the water increases along the x-axis. And what you can see is a general pattern of not very much algae at any temperature unless there's a lot of phosphorus to promote their growth. They encourage them, algae to grow. Now, there are other issues in relation to things like nitrogen and so on. I'm not covering that today. So, having established that all our lochs were heating up rather frighteningly quickly, we then worked on this project with Crew that's being published today, the report's being published today, of what are we going to do about it. So the thing to remember about algal blooms is they're affected by a lot of things, but they're particularly affected by warm, sunny weather. They float to the top, they grow very well. They like to be where there's a lot of phosphorus, and they like to be where there's a low flushing rate. They don't grow very quickly, so we don't want them flushing through too quickly if we actually want to grow them, which of course we don't. So when we look at this triangle, it's a bit like the one where you do fire extinguisher training. You take one of them away and then the fire goes out. So we can't take away the warm weather and we can't take away the change in flushing rate. But what we can do is focus on the sources of phosphorus and how to reduce those. So the first step is always to identify where that phosphorus is coming from by taking samples and measuring things rather than listening to what people say. Everyone would immediately say, well, it's all about the sewage, isn't it? It must be coming from the sewage works. But in actual fact, we ran this study, looked at where the sewage effluent was coming from, which are those purple catchments there. You can see that the red dots are not within them. And actually, in the end, we worked it out that only 1% of Scottish lochs actually receive phosphorus from sewage effluent. In Scotland, most of the sewage effluent goes into the rivers and out to sea. And so looking at the sewage problem is not the answer. And we looked a little bit further. I should mention that I was doing this with a very able team from James Hutton who were doing the catchment work. And we managed to show that the biggest source of phosphorus to these lochs was coming from runoff from farmland mainly into the lochs. So this is just a kind of flow diagram showing you what we did. So basically we combined these data sets on the left-hand side, the land cover data sets, climate change data sets, information about the lakes because the lochs, they all respond differently according to what type of loch they are, shallow, deep, large, small. So we got the sensitivity factors from there. And we looked at the amount of runoff and particularly phosphorus inputs to the lake, to the lochs, and then we ran them through a fairly simple lake response model that took into account phosphorus concentration and flushing rate. So once we'd done that and we got that all set up, we had to look at what the future scenarios were for reducing phosphorus inputs. And we took an approach that used these data from the socioeconomic change predictions to 2080 and climate change predictions to 2080. And just to explain what they are at the moment, we couldn't run all the climate scenarios, so we ran one that we thought was probably about how it was going to go with 1.5 degrees increase in temperature by 2080. We now know that actually we've already got that, so that's maybe a little bit low. Or we took another one, RCP6, which was an increase of 3 degrees by 2080. And we combined that with these shared socioeconomic projections for how people are going to behave and how they're going to manage the catchments into the future. So we did one SSP1, which is sustainability. So basically, everybody using sustainable management on land and also keeping the greenhouse gas emissions down. And we use the other one, SSP3, which is much more about what they call regional rivalry, which sounds as if everybody's going out to fight. They're not really going out to fight, but there's a lot of conflict between producing enough food, finding space for people, changing the land, and also higher greenhouse gas emissions because people don't want to change their behaviors. So we're going to take those two scenarios and just look and see what our work was predicting. So in terms of the land use change scenarios, what we used were some data recently published called Crafty GB or Crafty UK land use data. And we looked at that in relation to how land use was likely to change under these two different scenarios. So under the sustainable use scenario, the top three panels, you can see there's very little change. And under the regional rivalry scenario, you can see that a lot more of the land is being turned into farmland and agricultural land, a lot less wildscape land, and also it includes some draining of peatlands and things like that as being it's not the worst case scenario, but it's the worst case scenario that we looked at. So then we had to work out how do we quantify in our lakes the effects that all these things are having. And so we used 3 different ways. The first one was to look at the total phosphorus concentration in the lakes and how they were changing and going up or down. We then looked at the likelihood of the lochs exceeding World Health Organization levels for safe use of the water for swimming or for drinking. And you can see on the right here, that's very closely related to phosphorus concentration, so we could map that across. And then we looked at the SEPA targets for the lochs and compared the actual TP concentrations to see how much they were going to fail the SEPA water quality targets, or the World Water Framework Directive water quality targets. So we did that for both scenarios in 20, 20, 40, 60, and 80. You don't need to see those maps particularly clearly because we're going to zoom in on the bit that matters in a moment. So we did that for all of the different scenarios and all of the different measures of impact. But what we really need to look at is what are our lochs likely to be looking like by 2080. And what you can see here is that under the sustainable use scenario, there's a little bit of a change, a little bit of an increase in the north, but most of them have fairly low phosphorus concentrations, not particularly higher than they are already. If we go for the regional rivalry and the high greenhouse gas emissions, all of our lochs start turning red. And that means that their concentrations are starting to get really, really high. But we need to look at those concentrations in context because a high concentration in Loch Ness would be really worrying, a high concentration in Loch Leven not so worrying, so we need some context on that. In terms of the World Health Organization thresholds for safe use, we compared our phosphorus concentrations to that and the percentages of the risk of exceedance of those. And on the left is the sustainable use, sustainable land management scenario, and on the right is the regional rivalry one. So you get a lot more of the lochs. The water quality is degraded sufficiently to cause health issues from a WHO perspective. So what Scotland's quite concerned about, of course, is the failing or meeting WFD targets, and of course, for that you need to compare the phosphorus concentrations with the concentrations for particular lochs, and so that's what we did. There are less dots on this map because we didn't have as much data. And it was only for Water Framework Directive lochs, which are the larger ones. The previous ones, we were looking at 6,900 lochs. So for this one, you can see that if we think about good status by 2080 on the left there with a sustainable land use and sustainable management, a few of them are red, but no more than are red at the moment. Red being fail, and the pass is green. And if we go for the regional rivalry one, where with high greenhouse gas emissions and continuing climate change, many more of our lochs will fail Water Framework Directive targets. And that's for good status. If we look at high status, it gets even worse because there's a little bit of an increase under the sustainable management. On the right-hand side, though, many of our lochs will fail to meet good water quality status by 2080 under this regional rivalry, which we've kind of thought of now as being business as usual. We need to change business as usual towards more sustainable management to make this work for us. So key findings. So climate change increases the risk of harmful algal blooms, which are related to high phosphorus and high temperatures, low flushing rates. And unless we reduce phosphorus inputs to lochs and reservoirs, this is going to continue. The main source of phosphorus is runoff from land in Scotland. It may not be so in England. Some of the lakes there are contaminated by sewage. It's not very common in Scotland. So we recommend, having looked at various different scenarios of management, that the best approach is to reduce the amount of excess fertilizer applied to land by doing soil tests to make sure that we're not adding extra phosphorus, because that phosphorus that's coming off the farmland isn't going into the crops, it's just going to grow algae and other things in lakes. So the farmer's paying for it, but it's not producing extra crop. So we need to look at that, and we think that by using soil tests, we know that they've been testing some of this stuff in Northern Ireland with very good results, that we need to focus on that. So we showed, I think, that climate change impacts can be reduced by adopting more sustainable lifestyles. So it's not only about managing the farmland better, it's about reducing greenhouse gas emissions, it's about managing water supply better, because flushing rate is a big issue. And we showed that sustainable land use and greenhouse gas emissions would reduce phosphorus runoff by about 20% compared to current. And that would improve the water quality in about 85% of our lochs in any case. If we don't do that, we go for the high intensity land use, high greenhouse gas emissions. Into the future, we think this will double, more than double the phosphorus runoff and prevent 65% of our lochs from achieving good water quality by 2080. So there is a very big difference in the outcome depending on the direction that we take. So we'd like to say that our lochs and reservoirs are under threat from climate change, and they're under threat from climate change now. And if I had another 2 hours, I could tell you about the story of Loch Leven, if you ever want to hear it, where we had no algal blooms, climate change kicked in, and massive algal blooms. It is very closely related. And we know how to mitigate these impacts. We've shown that with this project. And we do believe that the time to start implementing that is now. It's far better to prevent the problem than to try and cure it later, which is expensive and often almost impossible to do. So what we'd like to finish with is I'll just acknowledge the team who are sitting around the room here from UKCEH and from James Hutton, who put in an enormous amount of work into this and with, I think, quite good results. The study was funded by CREW, and we're very grateful for that. I'm very grateful for the invitation to tell you all about it. And you all know what CREW is, so we'll leave that bit. So I'm going to thank you for listening, but I'm stopping early because we have made a project video. And that video is about to be played by the people up at the back there, I think. So it runs for 6.5 minutes. Enjoy.
Scotland's freshwater lochs are an important part of our natural heritage. They provide natural habitat for plants and wildlife, drinking water and recreational benefits to people across the country. Lochs are an internationally famous feature of the Scottish landscape. Think of Loch Lomond and Loch Ness, amongst others. There has been scientific interest in Scottish lochs for hundreds of years, but understanding how they will respond to climate change has never been more important. Globally, temperatures have risen by almost 1.5 degrees Celsius since pre-industrial times, rapidly altering our planet's ecosystems. Climate change is now an imminent threat to the quality of Scottish lochs. With air and water temperatures increasing and rainfall patterns changing, more storm events are flushing pollutants from land to water. Most Scottish lochs have warmed since 2015. As our climate changes, they are expected to experience even higher water temperatures or heat waves. Higher water temperatures could push lochs beyond their limits of resilience. These changes will reduce their habitat quality and recreational value, and endanger public health. Warmer waters and higher inputs of nutrients, especially phosphorus, increase the risk of algal blooms developing in our lochs. Algal blooms are rapid accumulations of algae and cyanobacteria in loch water that often float to the surface. Algal blooms can produce toxins that are harmful to people and wildlife. Like any other plant species, 3 main factors control the growth of algae: warm temperatures, strong sunlight, and a good supply of nutrients, especially phosphorus. Reducing any one of these factors will lower the risk of algal blooms. In the case of Scottish lochs, most of the phosphorus comes from agricultural fertilisers. excess fertiliser travels from land to water under wet conditions. This is called runoff. Under climate change, the UK is expected to become warmer and wetter in winter and hotter and drier in summer. We will also experience more storm events. These changes will increase phosphorus runoff into our lochs and increase the risk of algal blooms. While we can't reduce water temperatures and levels of sunlight, we can change the amount of phosphorus entering our lochs, especially as runoff. The question is, how? We could install more buffer strips. These are areas of vegetation that separate agricultural fields from rivers and streams, intercepting runoff. But this would only reduce runoff by about 1%. We can also lower phosphorus runoff by reducing any excess fertiliser applications to agricultural land. If we cut greenhouse gas emissions and reduce fertiliser application, phosphorus losses from land to water would likely decrease by about 20% by 2080. There are other ways of reducing algal blooms in our lochs. For example, removing historic pollution from sediment in the loch bed, or adding chemicals to make the algal blooms sink. But these measures are very expensive and do not provide a long-term solution to the problem. What if we don't reduce nutrient inputs to lochs? If we fail to cut greenhouse gas emissions and we don't introduce more sustainable land management practices, phosphorus losses from land to water are projected to more than double by 2080. Many of our lochs would then fail to meet their good water quality targets. At the moment, algal blooms cost Scotland at least £16.5 million per year in terms of water treatment, impacts on house prices, reductions in visitor numbers, and loss of biodiversity. However, the real costs are probably much higher, as this figure excludes medical and veterinary costs for people and animals affected by the toxins that algal blooms produce. At Loch Leven alone, the estimated cost of algal blooms is about £2 million per year. While we can't stop climate change, we can act to protect our lochs from its effects in the future. We must work with farmers, landowners, environmental regulators, and policymakers to co-develop sustainable, evidence-based solutions that will make our lochs more resilient to climate change. Combining low greenhouse gas emissions with sustainable lifestyle choices and reducing phosphorus runoff is the best way to prevent algal blooms. This will keep our lochs clean and healthy for future generations to enjoy. We understand the solutions. Now is the time to use them.
To Erica Zaja and to Juliet Stevenson, who did the voiceover for us, and I hope you like the video. Thank you.
Fantastic, thank you. That was great, yeah. So can I open the floor up to questions now, please? Slido?
We have a couple of questions from Slido. First question is, have farmers been involved in this study? Are there any plans to have co-created solutions with the agricultural industry? That's one question.
Okay, so the farmers were not involved in this particular study. We are planning to talk to them about this, and we didn't know what the result was going to be until a couple of months ago, so it might have said, well, it's all sewage works, it's not farmers anyway, so that's the next phase, isn't it? We're talking to the people who can help, getting them to understand that what the issue is and how urgent it is, And I do have some funding at the moment to talk to the farmers in the Loch Leven catchment, which we use as a sort of detailed demonstration study.
Oh, can I go with Kirsten, because you've asked one question already today?
Thanks very much for your fabulous presentation and the film, which was just brilliant. It's kind of asking you, beyond the funding that you've got, what do you see as next? You know, looking ahead the next 5, 10, 20 years, what would you really like to see happening with this work? Thank you.
Well, the first thing that we've talked about a lot today is taking what we know and what we've done to other countries, and so that they can see. And I already took it to the Environment Ministry in Chile last week. In about 3 weeks' time, I'm taking it to Brazil. So, because it's quite unusual to be combining these socioeconomic projections with climate change projections and applying them to lakes like this. What we need to do, though, is reduce the amount of phosphorus, particularly, that's going into the lochs. And to do that, we have to work within the catchment, with the farmers, with other people. I mean, it's not only farmers, is it? Because there are golf courses, there are people putting nutrients on their lawns. So working with the people who live in the catchment so that they understand the problem and how they can help.
Thank you. Are there any more questions on Slido?
The other question is, other than reducing the use of fertilizers, what's the role of NBS in preventing the worst of climate change-mediated effects from nutrient pollution in lochs?
Of nature-based solutions, yeah.
Thank you.
I personally think that you can put nature-based solutions in. We had a look at it, for example, buffer strips, they're the favorite one. What we showed was that they really don't have as big an effect as we need. I think nature-based solutions are very much the backup plan, that we need to really have policy about putting nutrients into catchments, across catchments in the first place. So I think nature-based solutions are a good idea in certain places, but they're not absolutely proven technology that's going to solve this problem.
Okay, thanks. Alan?
Yes, thanks, Linda, for a great presentation. I was just wondering about the lochs in the north and northwest and the islands where you don't have a lot of arable agriculture. I was wondering, is there a different mechanism there for trying to reduce the phosphorus input into the lakes?
Possibly, yes. So the maps showed a big change in those areas because the projected land use change into the future was to move away from peatlands and drain them and use them for agriculture, and that's why they all turned a rather nasty red colour. We were a bit stunned by that, and we actually went and had a look to see exactly why that had happened. It's possible that won't happen into the future, but we were looking for worst case scenarios. You didn't get so much of that under the sustainable management scenario.
May I ask you a question? So to reduce the inputs of phosphorus, obviously controlling it at source is one of the key messages. And farmers obviously are losing money by phosphorus just running into lochs. So what's the incentive, or what is there a change of behaviour required for farmers to adjust their application? I mean, what's going on and why are they over-applying that? I mean, is it just purely because of rain events that...
It's partly historical.
Okay.
That a lot of farmers, especially across the world, they just apply phosphorus because it makes things grow and get greener, and they like it. It's maybe what their fathers and other people have done with the land that comes into it as well. What we would like to happen is that soil testing takes place to find out how much needs to be applied to the land and when, because when you get these incredibly heavy rainfall events, which we didn't used to have when I first came to Scotland, 47 years ago, it just drizzled all the time. And now, and now we get sunshine, which is brilliant, but we get these big downpours, high energy rainfall that moves all this stuff into lochs. And so what we need, let's call them custodians of the land, because it's not only farmers. We need them to realize that the best management practices of the past don't apply anymore, and we need to look more closely at how we control storm runoff. And that's quite an important issue.
Oh, well, that's a really great finish, I think, to our crew lecture this year. So thank you very much for that really amazing talk. So can I please give Linda a round of applause?